What is a variable in Python? What are variables types in Python? How do they store values?
A variable is a name that refers to a value. In Python, you don't need to declare the type. In this example, name is a variable which stores a string value Python. Age is a variable that stores an integer value 24. Score is a variable which stores a float value 99.9. Each of these is a Python variable because it has a name identifier. Is assigned a value using equals sign. Holds data of a specific type, string, int, float, that are used later in code. Variables hold data such as model names, learning rates, datasets, and results.
Variables naming rules. Start with a letter or underscore. Use letters, numbers, and underscores. No spaces or symbols like exclamation mark and @sign. They cannot be a reserved Python keyword.
Data types in AI variables. Int, also called integer, its use in AI, a number of training epochs. What is an epoch in AI? An epoch is one complete pass through the entire training dataset by a machine learning model. Epoch equals one full cycle through the training data. When training an AI model, it learns by adjusting weights based on data. It doesn't learn perfectly in one shot, so it needs to see the data multiple times. That's why we use multiple epochs. The float type is the learning rate. The string is a model name or file path. Boolean, this check if a training is complete. List, it deals with probabilities and layer weights. Dict, a dict, short for dictionary, in Python is a built-in data structure that stores key-value pairs. It's incredibly useful in AI and machine learning for organizing data like configurations, metrics, parameters, and more. How do we assign and reassign values to a variable in Python for AI?
This line creates a variable named learning_8 and assigns it the float value 0.01. Learning_8 is a common hyperparameter used to control how much a model's weights are adjusted during training. A small value like 0.01 means the model learns slowly but steadily. Prints the current value of the variable learning_8 to the console. This line reassigns a new value to the same variable learning_8. Now, it holds the float value 0.001 instead of 0.01. This mimics the adjustment of hyperparameters. Sometimes during training, you may reduce the learning rate to fine-tune the model more carefully. This prints the new updated value of learning_8. The output is 0.001.
How do we deal with multiple assignments in Python for AI? First of all, let's start with regular Python. A, B, C equals 1, 2, 3. Assigns 1 to A, 2 to B, 3 to C, all at once. X equals Y equals Z equals 0 assigns 0 to X, Y, and Z with same value to all. Input_size, hidden_size, output_size equals 784, 128, and 10. Sets neural network layer sizes. Input_size equals 784, example. Pixels in an image. Hidden_size equals 128, neurons in hidden layer. Output_size equals 10, example. 10 classes like digits 0 to 9.
Working with lists in Python for AI. A list in Python is an ordered collection of items that can be changed, mutable. It's used in AI to store data like numbers, predictions, weights, feature values, or even entire datasets. The variable weights creates a list named weights. The list contains three float values, 0.25, 0.5, and 0.75. In an AI context, this could represent weights of neurons, probabilities, or feature importance values. Weights at index 1 accesses the second item in the list. Lists in Python are zero-indexed. That means the counting starts at 0, so weights 0 equals 0.25. Weights 1 equals 0.5. Print weights at index 0. This means that the output at index 0 will be 0.25. In other words, the weights at index 0 gets the first value in the list.
Print weights at index 2. The output at index 2 is 0.75. Weights at index 2 retrieves the third value, which is 0.75. Here is a visual representation of the output at index 0, 1, and 2.
How to create a dictionary in Python for AI. A dictionary in Python is a key-value pair data structure. It is used to organize data, metrics, or parameters. This line creates a dictionary named metrics. Here, the keys are accuracy and loss, and their corresponding values are 0.92 and 0.15. This is useful in AI to store model performance metrics like how accurate the model is or how much error, loss it has. The print line prints the value associated with the key, accuracy, from the metrics dictionary. Metrics, accuracy, accesses the value 0.92, so the output will be 0.92.
What's going on? Message: an error has occurred on line 5. Parse error: bad input on line 5. How come? Line 5 looked good to me.
Are you sure? Let's check again. Looks like we wanted to make a comment. You cannot have a comment or extra text after a colon like that, unless it's part of a statement, like a function, loop, etc. To fix it, you should either Option 1. Remove the colon and make it a comment, or Option 2. Move the comment to a new line. Furthermore, the comment working with lists is actually not accurate. Dictionaries are not lists. We can fix the comment to say, #accessing dictionary value.
Typecasting is sometimes needed for model compatibility. Let's declare a variable called number and assign to it a value that is a string 10. Our task is to convert this string into an integer. How do we do that? Well, we use what we call typecasting by declaring a new variable called number_integer equals sign and take the original number, surround it with integer. How to explain it in simple, human language? Imagine you have a sticky note with number 10 written on it, but as text, not a number. You can read it, but the computer sees it as letters, not as something it can do math with. So this is what typecasting does on this line. Take the text 10, not the number, just text. Turn it into a real number that the computer can actually add, subtract, or multiply. Store that number in a new container called number_int. Back to our bucket analogy. Bucket 1 number is a bucket holding the word 10, like how 10 is written in a text message. Bucket 2 int number is a machine that says, give me that bucket, and I'll extract the real number inside it. Bucket 3 number_int is a new bucket that now holds the actual number 10, ready for math. Here comes a challenge. When you print number and number_int, you get 10 for both output. How do you know whether the output is an integer or a string?
For number, this is what's happening. Number is, this is a text message, a string. Plus number. This adds the value stored in the variable number, which is 10, also a string. Plus, this is a string. Adds more text. All the parts are strings, and the plus symbol joins them together. For the number_int, we have the following. Number_int is just some text to describe what we're printing. String, number_int. This converts number_int, which is a number, to a string.
Why?
Because you can't add a number to text directly. It would cause an error. Plus, this is an integer. Adds more text that tells us this value is an integer.
We have an error message saying that we cannot concatenate string and integer objects on line 6. What does this mean, and how do we fix that? Well, this means that Python cannot allow us to join a string with a number. We must convert the integer to a string using the string method str before joining it with another string.
9. Using variables in AI libraries with NumPy. First of all, we import the NumPy library and give it the alias NP. NumPy equals a powerful numerical computing library used heavily in AI, machine learning, and data science. Using NP lets you call functions like np.array more easily. The second line creates a regular Python list called data. The list contains 3 integer values, 1, 2, and 3. In AI, you might use lists to store raw values like features, pixel values, or label counts. This line, array equals np.array data, converts the list into a NumPy array. np.array data takes your Python list, 1, 2, 3, and transforms it into a NumPy array object. NumPy arrays are faster and support vectorized operations, like math across all elements. In AI, arrays are used to handle tensors, vectors, matrices, and model inputs. Finally, print array mean. This prints the mean or average of the NumPy array. Arrayed mean method computes the average of the numbers in the array. 1 plus 2 plus 3. Divide 3 is equal to 2.0. Print method displays the result, 2.0.
Create a variable named epochs. Set it to 7, meaning we'll simulate 7 training cycles, or epochs. In machine learning, an epoch is one full pass through the entire training dataset, remember? Then set a variable called learning_rate to 0.01. This is a hyperparameter that controls how much the model updates during training. Next, accuracy equals 0.9. Starts with a simulated accuracy value of 0.9, meaning 90%. This will be updated inside the loop to simulate model improvement. For epoch in range, epochs starts a loop that will run from 0 to 6, 7 times total. On each pass, the variable epoch will represent the current epoch index, starting from 0. When it comes to accuracy plus equals 0.02. Increase the accuracy by 0.02, meaning plus 2% every epoch. This simulates your model getting better as training continues. Print the current epoch and accuracy. Epoch plus 1 makes it print from 1 to 7 instead of 0 to 6. Accuracy. 0.2f formats the accuracy to 2 decimal places, example, 0.94.
Epoch 1, accuracy, 0.92. Epoch 2, accuracy, 0.94. Epoch 3, accuracy, 0.96. Epoch 4, accuracy, 0.98. Epoch 5, accuracy, 1.00. Epoch 6, accuracy, 1.02. Epoch 7, accuracy, 1.04.
Practice tasks. 1. Create a variable for model_name, dataset_name, and batch_size. 2. Make a list of 5 probabilities. 3. Use a loop to simulate improving accuracy each epoch. 4. Create a dictionary of model metrics. 5. Convert a user input string into an integer for number of epochs. Bonus tip: debugging variables. Use print, type, variable to inspect unexpected data types. Happy learning, and see you in the next one.